Welcome to the edge of the universe, a place where time, space, and reality stretch beyond imagination. Today, we embark on a journey that will change the way you see the cosmos forever. Since its launch in 2021, the James Webb Space Telescope has been peering deeper into the universe than ever before. Now, in 2024, it has unlocked secrets that are altering our understanding of the universe. The discoveries we're about to reveal are truly mind-blowing. Imagine this: 13.8 billion years ago, the universe was born in the Big Bang. For hundreds of millions of years, there was only darkness, no stars, no galaxies, just an expanding, chaotic void. But then, something extraordinary happened. The James Webb Space Telescope has allowed us to witness this moment, the birth of the first galaxies in an era known as cosmic dawn. JWST has discovered galaxies that formed just 200 to 300 million years after the Big Bang, the most distant objects ever observed. What's even more surprising is that these galaxies aren't the chaotic clusters scientists once thought they would be. These early galaxies display structure, some with disk-like shapes and clusters of stars, far more organized than expected. It turns out the universe was more structured and much sooner than we ever imagined. This discovery changes our understanding of how galaxies formed. The early universe was not as chaotic as we thought. In fact, it was already efficiently building galaxies from the earliest moments of cosmic history. The raw materials, gas, stars, and dark matter, came together rapidly, forming these organized systems far earlier than our models predicted. Some of these galaxies may also harbor massive black holes that grew quickly. The presence of quasars, extremely bright, active galaxies powered by supermassive black holes, suggests that black holes in the early universe grew at astonishing rates. It is possible that these black holes formed through the direct collapse of gas clouds, growing to billions of times the mass of our Sun in record time. The ability to observe these early galaxies with JWST is helping astronomers unlock the mysteries of the universe's formation, from the first stars to the earliest black holes, and how the cosmic web that connects galaxies began to form. But that's not all. JWST has opened a window into the large-scale structure of the universe. By mapping these ancient galaxies, JWST has revealed the delicate dance of dark matter, gravity, and gas that forms the cosmic web, a vast network of galaxies interconnected by dark matter. This structure is like a map of the universe's skeleton, and JWST has provided us with an incredibly detailed view of how the universe's largest structures began to form. Now let's move beyond galaxies and look at exoplanets, worlds that orbit stars outside our solar system. The James Webb Space Telescope isn't just looking deep into space, it's also looking for life. One of JWST's most thrilling capabilities is its ability to analyze the atmospheres of distant planets. It does this by observing the light that passes through these planets' atmospheres as they orbit their stars. The chemical composition of these atmospheres can give us clues about whether life might exist there. In 2024, JWST made one of its most exciting discoveries yet: the detection of potential signs of life on an exoplanet. This world, called K2-18b, is 124 light-years away from Earth in the constellation Leo. K2-18b is about 2.6 times the size of Earth, and it orbits within the habitable zone, the region around a star where conditions could allow for liquid water, a key ingredient for life. JWST detected methane and carbon dioxide in K2-18b's atmosphere, both molecules that can be produced by biological or geological processes. But what really caught scientists' attention was the potential detection of dimethyl sulfide DMS, a molecule produced almost exclusively by living organisms on Earth. This discovery is tantalizing because it represents the first time a potential biosignature has been detected on an exoplanet. While it's still too early to confirm whether life exists on K2-18b, this finding has propelled the search for extraterrestrial life into a new era. If life exists on this distant world, it may be very different from life on Earth, perhaps thriving in conditions we've never imagined. JWST has shown us that planets like K2-18b which aren't Earth-like, could still host life in their own unique ways. As the telescope continues to observe more exoplanets, it's possible that we'll discover even more worlds that could harbor life, each more exotic than the last. And the excitement doesn't end there. JWST has opened a door to studying planets that fall outside our traditional notion of habitable worlds. We're now exploring planets with thick atmospheres, mysterious chemical signatures, and even water-rich environments that may host alien life in ways we've yet to fully understand. Now, let's explore one of the greatest mysteries of the cosmos: dark matter. This invisible substance doesn't emit light, doesn't reflect it, and yet it makes up nearly 27% of the universe's mass. Dark matter can't be seen directly, but JWST has helped scientists study its effects through a phenomenon called gravitational lensing. This occurs when massive objects, such as galaxy clusters, bend light from more distant galaxies. By studying these lensing effects, JWST has revealed detailed maps of dark matter's distribution across the universe. One of the most exciting breakthroughs in 2024 came from JWST's observations of the galaxy cluster Abell 2744, also known as Pandora's cluster. By examining how light bends around this massive cluster, JWST detected previously unknown concentrations of dark matter. These findings reveal how dark matter influences galaxy formation and its impact on the universe at large. Dark matter acts as a cosmic scaffolding, providing the gravitational framework that allows galaxies to form and grow. Without it, galaxies would simply fly apart due to their rapid rotation. Thanks to JWST, we now have a clearer picture of how this invisible substance shapes the structure of everything in the cosmos. Understanding dark matter remains one of the biggest challenges in astrophysics, but JWST is bringing us closer to solving this cosmic mystery. By studying its interaction with visible matter and its influence on galaxy evolution, JWST is helping unlock the secrets of this hidden force. Our journey continues into the vast network of galaxies known as the cosmic web. The intricate structure of galaxies, gas, and dark matter that forms the backbone of the universe. With JWST, astronomers are mapping this cosmic web in unprecedented detail. The telescope's ability to observe galaxies across vast distances allows us to track how they've grown and evolved over billions of years. One of the most fascinating discoveries in 2024 was the detection of cosmic filaments, thread-like structures that span hundreds of millions of light years and are made up of galaxies, gas, and dark matter. These filaments are the building blocks of the universe's large-scale structure, and JWST's observations have shown that galaxies within these filaments are experiencing bursts of star formation at higher rates than galaxies in less dense regions. The interactions between galaxies, gas, and dark matter in these filaments create ideal environments for star formation. As galaxies pass through the dense regions of the cosmic web, they collide with other galaxies, triggering the formation of new stars. JWST's infrared instruments have allowed astronomers to peer into these star-forming regions, revealing hidden areas of intense star birth that were previously obscured by dust. These observations are helping scientists understand how galaxies grow and evolve within the cosmic web. Galaxies aren't isolated. They interact with their surroundings in complex ways, influencing their growth, shape, and star-forming activity. By studying these interactions, JWST is painting a detailed picture of how galaxies form and evolve over billions of years. Next, we dive into one of the most mysterious and powerful objects in the universe: supermassive black holes. These cosmic giants, millions or even billions of times more massive than the Sun, sit at the centers of most galaxies, including our own Milky Way. In 2024, JWST made an astonishing discovery: a supermassive black hole in a quasar over 13 billion light-years away. This black hole, known as J0313-1806, is more than 10 billion times the mass of our Sun. What makes this discovery even more incredible is that this black hole formed just 670 million years after the Big Bang. This discovery challenges our understanding of how black holes form and grow. How could such a massive black hole have formed so quickly in the early universe? Theories suggest it may have formed through the direct collapse of a massive gas cloud, rather than the slow accumulation of matter over time. JWST's observations of quasars and the black holes at their centers are helping scientists unravel these mysteries. By studying the light from these distant objects, JWST is providing new insights into how black holes influence the growth of galaxies and how they may have shaped the evolution of the universe. Stars are the engines of the universe, creating the elements that make up planets, life, and everything we see. But stars don't live forever. When massive stars die, they explode in spectacular events known as supernovae, and JWST has given us a new window into these dramatic deaths. In 2024, JWST provided stunning observations of the supernova remnant Cassiopeia A, the glowing debris left over from a massive star's explosion. By studying the infrared light from this remnant, JWST was able to map the distribution of heavy elements like oxygen, carbon, and silicon, elements that are essential for the formation of planets and life. These elements are flung into space during the supernova explosion, where they mix with gas and dust to form new stars and planets. JWST's observations of supernova remnants are helping scientists understand how these elements are recycled throughout the universe, fueling the ongoing cycle of cosmic creation. Cassiopeia A offers a perfect laboratory for studying the aftermath of stellar death. The supernova explosion that created this remnant occurred about 11,000 years ago, and its glowing debris field stretches across 10 light years. As JWST peers into this remnant, it's giving scientists unprecedented details about how heavy elements are distributed after a supernova, showing where they have drifted into space and how they will one day contribute to the birth of new stars and planetary systems. This cycle of death and rebirth is a fundamental process in the universe. The elements created in the hearts of dying stars are spread throughout galaxies, where they form new stars, planets, and potentially even life. JWST's ability to see through clouds of dust and observe these elements in detail is revealing how the universe continually recycles matter, allowing for the creation of new stars and planets billions of years after the Big Bang. These insights help us understand not only the universe's past, but also its future. As stars like our Sun eventually burn out and die, their material will return to space, seeding the formation of the next generation of stars and planets. JWST's observations of supernovae and stellar death are showing us how the universe renews itself, ensuring the continuation of star formation across cosmic time. The discoveries made by the James Webb Space Telescope in 2024 have revolutionized our understanding of the universe. From witnessing the formation of the earliest galaxies to detecting potential signs of life on distant exoplanets, from unraveling the mysteries of dark matter to observing the explosive deaths of stars, JWST is revealing the cosmos in ways we've never seen before. And this is only the beginning. As JWST continues to explore the universe, who knows what new wonders we'll uncover? One thing's for sure, the universe will never look the same again. Thank you so much for watching our content. If you enjoyed this video, be sure to give it a thumbs up and follow us for the latest updates on space exploration and cutting-edge discoveries. Stay tuned for more exciting insights from the cosmos.